So let's go back to Aristotle.
Okay.
Aristotle has like a huge modern fan club where he can do no wrong.
Right.
But in physics, almost everything he said was wrong.
Wow.
So that's why we don't.
What a dumbass.
So if you read his writings, I'll paraphrase one of them. It's objects will fall at a rate proportion to how much mass they have.
Right.
So if you follow that reasoning through, if something weighs 10 times as much, it should fall 10 times
as fast. Yeah.
Right?
And
everybody just agreed with that.
I mean, didn't it occur to them that maybe we should test this?
No, because testing an idea had to emerge as a thing to do.
It's so funny that we take the scientific method for granted.
So that's what people thought until Galileo said, let me test this.
Right.
Let me test whether things fall at the same rate. Now, it is rumored that he didn't actually perform this experiment, that he did it just as a thought experiment.
Okay.
But in either case, it's correct.
Right.
Okay?
Worked. Yeah.
So the experiment as described, he goes to the Leaning Tower of Pisa, gets a heavy object and a light object.
Mm-hmm.
But they both have some density to them so that air is not a big factor. So he drops them, they fall exactly the same rate to the ground.
Wow.
And this experiment was repeated in the Apollo missions. So in the Apollo mission, Apollo 15, it turns out, they had a hammer and they had a feather.
And we thought that where would be a better place to confirm his findings than on the moon.
How come no one has ever talked about this when it comes to the Galileo experiment that they did at Apollo 15 on the moon?
So,
wait, you know why? Because we didn't go to the moon. That's why we don't talk about it.
So on the moon, he's got the hammer, he's got the feather.
Right.
And lets go of them, and they both drop at exactly the same rate. The feather
too cool.
and the hammer. But what made it work is that there was no air.
Right.
So if you got some cavity or some room where you evacuate the air, you could do that
still
experiment
work here on Earth.
On Earth.
Right.
Okay. So you didn't need the moon to make that happen.
Right.
Okay.
Right.
So let me remind you just how sight works, or how the optics of sight works.
Okay.
So light comes through the air, and air has a certain density to it.
That makes sense.
And it goes through the pupil of your eye, and on the other side of the pupil is the lens. It goes through the lens, and the lens bends the light.
Of course.
Okay? And then brings it to focus to an image on the back of your eyeball.
Right.
On the retina. And then it's an upside down image. Yeah. So your brain inverts it and does what it needs to do.
Cameras used to do that.
The single lens reflex cameras, why you're not looking directly through, it comes up and across. In that bend, it makes the image right side up. Same with the binoculars.
Right.
You ever see binoculars where it's narrow up front and then it goes wider there? That bend rectifies the image. You think, it's just the design? No, it is so that you don't see everything upside down the way the lens does. So the light comes through and it focuses. Your lens is focusing the light that came through the air. And anytime light changes from one medium to another, it bends, like in water.
Yeah.
Like you see, the famous one is with a straw. So if you like to fish, but don't like waiting around with a rod and a wire, you might do it with a bow and arrow.
Right.
Okay. These bow fishing. So you just see and then you shoot.
Spear fishermen do the same thing.
I guess so. Exactly. So they know whether or not they've studied the optics of it. They know that if you aim where you see the fish, you'll miss the fish.
You're not going to get it.
Right.
Right.
Because the light bent on its way out.
Right.
So they have to aim below where they see the fish, because that's where the fish actually is.
Right.
All right.
Okay.
All right. So now you say, all right, let's say we do equator. Now you look up at the sun with filters. Mm-hmm. Then you see this sharp edge. Mm-hmm. All right. Mm-hmm. The edge of the sun has an edge.
All right.
Okay. But wait.
Uh-oh.
The sun is made of what?
Plasma.
Plasma, it's just gas, basically.
Gas,
okay. Yeah. Plasma gas. When was the last time you saw gas have a sharp edge to it?
That'd be my Uncle Daryl.
When that smell moved across the room, it had a sharp edge.
Sharp edge.
You either in it or out of it.
Man, it's time to go. Yeah.
The spherical ball that is the sun,
right.
The oblate spheroid that is the sun, we speak of an edge, but that's an edge made of gas.
Right.
Okay?
How do you even have that?
That's my point. It's like Earth's atmosphere.
Right.
Where's the edge of Earth's atmosphere? No, there's no edge.
Right.
It's gas that becomes sort of thinner and thinner.
And you know you reached it when you're like.
So when we see the sharp edge of the sun, in practice, we were referring to what's called the photosphere.
Oh.
The photosphere is a layer of the sun's atmosphere, which is the last point of contact with the photon trying to get out of the sun.
Oh, okay.
Okay? And now the photon can move at the speed of light in a straight line. Until that point, it was bouncing back and forth among other molecules and other atoms and other particles. By the way, had that photon been moving in straight lines, you'd be able to see deep inside the sun.
Oh.
That's what light moving in straight lines means.
Right, yes.
Why is a window transparent to you? Because the light moved in a straight line through the window.
Right.
But then I smoke the window. What do you do when you
frost?
I frost the window.
Right.
And now the light, I can't get through. I got to jiggle a little bit. I'll still come through, but I'm not in a straight line.
Right.
You cannot see through the window.
No, yeah, the window's lit up, but you can't see what's on the other side.
The light's coming through, but it's not a straight line.
Not a straight line.
Okay.
Yeah.
All right. So the photon gets to this place, an edge, where it can now escape for free.
Mm-hmm.
There's not enough above it to keep bouncing around.
Right.
That edge is the photosphere, and that is our definition of the edge of the sun. That's only using visible light.
Oh, God.
Okay.
I knew there had to be a twist to this.
So we are visible light biased.
Right.
I don't mind that, but don't declare that this be the diameter of the sun if the diameter of the sun is simply what your own damn eyeball can see.
Right. Wait,
Okay.
oh my.
Right? So if you look at the sun in X-rays,
Okay.
it has a different diameter.
Really?
X-ray photons are coming from a different place, a
Okay.
different surface. So we are biased. And I think we need the occasional reminder that we are eyeball biased. Diameter of the sun is where the visible light comes from. And specifically, yellow light. Okay, right in the middle of the spectrum. Red, orange, yellow, green, blue, violet. Right in the middle. Let me keep going.
Go ahead.
There's a layer of sun's atmosphere on top of that.
On top of this photosphere.
Yes. You know what that's called? The corona.
Oh, yeah, okay.
That's part of the sun.
That's part of the sun.
Why is your diameter not including that?
Right.
That's part of the sun. The corona, depending on where the sun is in its cycle, can be really big or really small. So that changes on an 11-year cycle. But wait, the sun has a magnetic field that extends beyond the corona.
Right.
That's called the magnetosphere. Shouldn't that be part of the diameter of the sun?
It's part of it.
Like part of the sun?
It's part of it.
All right?
Yeah.
All I'm saying is, if you seek the truth, my son, be aware that the truth has many faces. One face may deceive you into thinking that it is the face of the answer to that question. Let you not be blinded by how authentic its truth may seem, because others will be speaking their truth quietly and clearly, and you must listen to them as well.
Do I have to snatch a pebble from your hand now?
Go ahead. Snatch the pebble from my...
Wow, you got some quick reflexes, man. All right.